A very good evening, students. So, in yesterday's class, at last, we discussed this example that why should we use CNN to process images when we have other neural networks too. So, usually we use feed-forward neural network. Uh, we can also use feed-forward neural network to process images. So, when we have feed-forward neural network, what is the need to use this convolutional neural network? So, at last, we discussed this example, which I'll repeat again that what are the disadvantages of using our conventional feed-forward neural network, which motivates us to use this CNN. We also discussed, like before this, we discussed one example of that MNIST, and both these examples, these are just to explain you that how many neurons, a huge amount of neurons are required in input layer of our traditional neural network to process images. So with both these examples, this was like conveyed to you that so many neurons are required in input layer, which is not feasible because if there are more number of neurons in input layer, then you will have those many weights and like a huge amount of computation will also be carried out. So this is the example to explain that how many neurons, like to give you idea that how many neurons are required to even to process such a small image. So in this MNIST example, we considered image of like it includes in fact images of this resolution 28 cross 28 cross 1, and we computed that this means how many pixels are there in one MNIST uh, one MNIST image. So 784 neurons are there. Now, then we discuss that if suppose it's not 28 cross 28 cross once in black and white image, let's assume we have color image. We want to process color images. And we have assumed this resolution of image 1000 cross 1000, which is very like bare minimum, right? Because then only you will have a clear image, good quality image. So 1000 cross 1000 results in 10 raised to 6. So 10 raised to 6 pixels are there in one image, and to process this 10 raised to 6 pixels, 10 raised to 6 neurons are required in input layer. So that way, like number of neurons for input layer are considered. And for this figure, this image is considered 224 cross 224 cross 3 because it is color image. So color image means this many neurons are required. So, but when we use this convolutional neural network, it reduces the dimension of image from 224 cross 224 cross 3 to 1 is to 1 is to 1000. So now only 1000 neurons are required because we have used CNN to reduce the dimensions of image. And for the same purpose, we discussed this another example. Let's say suppose you have 64 cross 64 image and your problem is classification, binary classification problem. You want to know whether image contains cat or not, yes or no. Right. So it's a binary classification problem. But 64 cross 64, or if we consider better resolution image, then it may be 1000 cross 1000. Okay, now if we want to feed this 1000 cross 1000 image to our conventional neural network, then what would be the value of n? That is number of neurons in input layer. That would be if it is color image and the resolution is 1000 cross 1000, then this n, that is total number of neurons in input image, would be 1000 cross 3 because it is color image. Right, even like for such a small image 64 cross 64, if we consider it as a color image, then 12k 12,000 neurons are required. And for 1000 cross 1000, how many neurons are required? 1000 cross 1000. And because there are three channels, color channels, it is 10 raised to 6 into 3 million. So you can see that 3 million, here you can see that 3 million input neurons would be there, which is very, very, very high number. And it's like the size of the structure of this neural network would be very complex. And it will take a lot of processing time if you want to train that neural network, right? So this is the main disadvantage of this, that it requires heavy computation, our traditional neural network. Okay. Another reason is that why do we need CNN? That was the first reason, right? Which we discussed yesterday. The second reason is that when we want to process images using our traditional neural network, like feed forward neural network, what it does, suppose we have this image of 4 cross 4 pixels. The resolution is 4 cross 4, 16 pixels are there. Let us assume that it is 4 cross 4 pixel. So it is black and white image and 4 cross 4. So only 4 into 4 into 1. So only 16 pixels are there. And if we want to process the 16 pixels, if we want to train our neural network with this 16 pixels, there would be 16 neurons in your input layer, right? So see this, X1 to X16 neurons would be there because 16 pixels are there. So they will have either black or white, like, okay. So this is the neuron. Now, when you train this, how you train this, you are feeding all 16 pixel values at the same time to your feed forward neural network. It learns from that. Okay. Now to give enough learning, we can have multiple epochs, right? Multiple rounds will be there. So the same image will be fed to this neural network again and again. And what this traditional neural network, like feed forward neural network will learn, it learns that uh, the cat is usually, the picture of cat should be in this part of the image, that is upper left part, because in training image cat is located in upper left part. So all the time we feed this 16 pixels, like in all the epochs we feed this 16 pixels, and through repeated learning it learns that cat should be located in upper left part of the image, then only it is cat, otherwise it may be some other object. Okay. Now, after training your traditional neural network, like feed forward neural network, with such kind of images, if you feed images like this, below image, where cat is located in uh, right bottom right corner, so it may not, your trained neural network may not identify this image as the image of cat, because it has learned that the cat picture is usually, like, it has also learned the location. When you feed this kind of images to a traditional neural network, it learns the location to position to. So it has learned that cat should be located in this part of the image. It cannot be in other parts of the image. So it may misclassify this image. Okay. So this is another problem with our traditional neural network, right? Because we feed all pixels together, it learns, and it learns position also along with other things. So to overcome this such problems with traditional neural network, like feed forward neural network, we have this convolutional neural network. So now let us learn what is neural network, what is its architecture, how it overcomes the problems with traditional feed forward neural network. Okay, so let us learn this let us learn this convolutional neural network now. Okay. So, as you can see, like to overcome the problem with feed-forward neural network, we can use like this CNN. This figure shows the sample architecture of convolutional neural network. As it can be observed from this figure, there are 4 building blocks of convolutional neural network. There are 4 building blocks of this convolutional neural network. The one is convolutional layer. This is convolutional layer. Then activation layer, right? Here ReLU is used in this figure. So convolutional layer, ReLU layer, then pooling layer is there. And at last, you can see that fully connected layer is there. So you can see that this is the architecture. The whole figure represents the architecture of convolutional neural network. But you can see that in this convolutional neural network, this block like convolutional layer plus pooling layer, they are repeated. Okay, so this convolutional layer, activation function, pooling layer, and this fully connected layer, these are the 4 main components of convolutional neural network. Clear. multiple convolutional layer, multiple pooling layers, and one fully connected layer. So in each layer, the features are extracted here, like convolutional. We have multiple convolutional layers, we have multiple pooling layers. So in each layer, the features are learned by itself, because we discussed that this convolutional neural network, this deep neural network, they learn features themselves. We do not need manual intervention. So that is the advantage of using CNN. Okay, so you can see that now here in this figure, this feature extraction layer, which is called convolutional layer. This is pooling layer. It shifts and distortion, variation, or subsampling layer. It is also known as this with these names: shift layer, distortion, invariation, or a subsampling layer. Okay, so this is a convolutional, and again, like we have, this is one convolutional layer, pooling layer. Again, we have convolutional layer C and pooling layer, subsampling layer or pooling layer S. So we can have such. Here you can see three dots. Here you can see three dots. So because such multiple blocks may be there, and each block consists of convolutional activation and pooling. So we can have n number of such blocks in your convolutional neural network, and at the end we have that fully connected layer to carry out classification. Okay. Okay, now let us discuss some terms associated with this convolutional layer. Convolutional layer. So, in fact, let us discuss all these four major components one by one: convolutional layer, activation function, pooling layer, and fully connected layer. So, let us discuss them one by one in detail. Convolutional layer, in as we know, in a neural network, we use filter, and filter is sometimes called kernel, right? So it is also known as kernel. Okay, so a kernel is passed over the image, viewing a few pixels at a time. Let's say, for example, 3 cross 3 or 5 cross 5. Then the convolutional operation is carried out, and which is a dot product of original pixel values with weights defined in the filter. So filter is nothing but weight matrix. Okay, so it is also called weight matrix, it is also called filter, it is also called kernel. So let us assume that usually we use the kernel of this size, irrespective of the, please listen carefully, irrespective of the size of the image, we usually choose kernel or weight matrix of this size, 3 cross 3 or 5 cross 5. Then what is convolution operation? Convolution operation, which is performed by convolutional layer, is a dot product of the original pixel values with weights. So we multiply input values with weights, which is what we do in our neural networks, like traditional neural network, right? Input values are multiplied by weight values. Okay, so here also in convolutional layer, convolution operation is carried out. And what is convolution operation? It is a dot product of the original pixel values with weight values defined by the filter, which is usually of this size, 3 cross 3, 5 cross 5. Okay. And then the next step is the results are summed up. Once we multiply them with weight values, what we do? We sum up them so that we can pass it to activation function, right? So the results are summed up into one number that represents all the pixels the filter observed. Okay. The objective of, so these are the three steps carried out by convolutional layer. The objective of this convolutional operation is to extract the high level features such as ages, etc. from the input image. So what's the objective of this convolution operation? To extract the high level features. All images, they have high level features as well as low level features. So objective of this convolution operation is to extract the high level features, okay, such as ages. Age is considered as the high level feature. Now, this convolutional network need not be limited to only one convolutional layer. That we have discussed, that we can have several convolutional layers. And conventionally, the first convolutional layer is responsible for capturing the low level features such as, sorry, yeah, conventionally, the first convolutional layer is responsible for capturing low level features. With added layers, the architecture adapts to the high level features as well. So this is how, like, I'll show you with examples that how it extracts the different types of features. Okay. So here I have included one example that how it processes the image. Okay, be with me here with this when we discuss this example. This example demonstrates the working of convolutional layer, or you can say working of convolution operation. Okay, so how it works. So we have an image, let us say we have an image of dimension 5 cross 5, right? This is just a sample image. Please remember that in reality, we have images of 1000 cross 1000 or higher than that. Because yesterday only we discussed that today we have images in megabytes. So resolution of those images may be 1000 cross thousands or higher than that. Okay. But here for simplicity, we have considered an image having resolution or having size 5 cross 5. Fine. So the number of channel, let us say it is one. If it is if it is color image, then such three matrices would be there. Such three matrices would be there. One matrix to represent the pixel values or pixel intensity of red channel. Second matrix we may have for pixel intensity of blue channel, and then for green channel. So we can have such three matrices if we are processing color image. But let us assume that it has only one color channel, and this is the dimension is 5 cross 5 cross 1. So this matrix, this 5 cross 5 matrix, it represents your input image. Okay, let us assume that the kernel we are using to process this image. Okay, listen, now we want to feed this image to neural network to train the neural network. So how can we feed this neural network? How can we feed this image to neural network? One way is input all the 25 pixels at a time. So for that, we need 25 neurons in our 25 neurons in our input layer. But we don't want that. So what can we do instead of that? Now, what can we do? We can process this image in parts. We can process this image in parts. Okay. So which part of image we are processing? So we are processing 3 cross 3 pixels at a time from this image. 3 cross 3 pixels. Okay. How we are processing 3 cross 3? Because we have chosen weight matrix of 3 cross 3. If it is a big image, we can consider 5 cross 5 also. Okay. So we have considered 3 cross 3 filter, 3 cross 3 weight matrix. You see this, these are the different names: filter, kernel, set of weights, feature detector. Okay. These are the words used interchangeably for this weight matrix. So we are using 3 cross 3 weight matrix to process this image, which is represented by pixel values. Fine. Okay, so how this image is processed? You can see that we have like selected K. Okay, kernel is 3 cross 3, and now kernel shifts 9 times over this image. Why 9 times? Because it processes this image like this. Now you see the right side figure. Okay. Yeah, it starts with first, then next 3 columns, then next 3 columns. Now, then see the block. So such 9 blocks are there. Such 9 blocks, 3 cross 3, 9 blocks are there, which are overlapping. So this kernel, which we have chosen, kernel means weight matrix, set of weights. This kernel shifts 9 times because of stride length 1. I'll tell you what is stride, but it shifts 9 times because we have considered stride length 1. This is non-strided. When stride length is 1, it is called non-strided operation. Now, every time performing a matrix multiplication operation between kernel and the portion of image over which the kernel is uh, hovering, right? So you can see how we are processing this block. So this is weight value 1, this is input value 1. So 1 and 1 will be multiplied. Okay, please be with me and you can do this computation in your notebook. This is the part of your image which is highlighted by yellow color. These are your weight value, these are pixel values, and these are weight values. So what we do, we multiply weight value with pixel value. So this 1 and 1 will be multiplied. This 0 and this 1 will be multiplied. This 1 and this 1 will be multiplied. This 0 and this 0 will be multiplied, and so on. Right? Once we multiply them, we add all the values. And we add all the values, we are getting value 4. So you can see that convolved feature map, it contains value 4 for this block of the image. Right now, similarly, now this kernel will shift to the next 3 cross 3 block. So when it shifts to next 3 cross 3 block, you will get value 3, then 4, then 2, then 4, then 3, and this way. So this would be the output of your convolutional layer, which is convolved feature. This is the output when you feed your image to your convolutional neural network. This would be the output. Okay. So the filter moves to the right with a certain stride value till it passes to complete width. Moving on, it hops down to the beginning of the image with the same stride value and repeats the process until the entire image is traversed. Now you can see that when entire image is traversed, this matrix is filled. Right? So these are the values. I hope this is clear that how this convolution operation is carried out. Okay. See, these are multiplied. The next block, the next block, the next block, the next block. Such 9 blocks are there because stride value is 1. So such 9 blocks are there and they are processed and we get values. Okay. So this is the output of convolutional layer. Stride denotes how many steps we are moving in each steps in convolution. So here we are moving 1 step. So stride is 1 because हम एक block के बाद एक ही row, एक ही column को skip करके next पे जा रहे block पे. So stride is 1 here. Okay. So this is like how 5 cross 5 image is processed using 3 cross 3 filter, and this is the output generated from the convolutional layer. Okay, so this is the size. Now, what is the size of output? आपने जो image feed की थी, उसके size क्या है? Image size is 5 cross 5. Okay, output क्या कौन सा generate हुआ? 3 cross 3. So I hope you agree that dimension is reduced. Are you all with me? Right? Is this clear to everyone? Write yes or no in chat box. How the size of this input image is reduced. Input to convolutional layer was 5 cross 5 and output from convolutional layer is 3 cross 3. So I mean to say that the dimension of image is reduced. It was 5 cross 5 and now it is 3 cross 3. And you can also see that yesterday there was a question that there would be information loss. But you can see that there is no information loss because we have processed each pixel of the image. Rather, we have processed it multiple times. So each pixel is taken into consideration when we are processing this image. No part of the image is left unprocessed. No pixel of the image is left unprocessed. So each pixel is processed. So there won't be any information loss too. Right? So this is how the dimension is reduced. Now, this is the output of only first convolutional layer. Now, this output is fed as input to, it is given as input to next convolutional layer. Further, its dimension is reduced. Right? Now, this is just a sample. This is just an example. So we have considered 5 cross 5. But in reality, when we have 1000 cross 1000 images, the size of images in like 1000 cross 1000, you will get reduced size image at the end. Sometimes it is in bytes. Sorry, I mean kilo, 100 bytes. From 1000 bytes, it is now, it may be reduced to 100 bytes. Fine. So this is the example. Okay. Now, how do we compute the size of the output? हम एक convolutional layer में जो input image देते हैं उससे जो output मिलेगा, how do we compute the size of that output? So here you can see This is the formula that how do we compute the size of the output. You can see in this formula that here the formula is W minus F plus 2P divided by S plus 1. So what is W? It is size of the input. What is the size of the input in our example? Are you all with me? I hope you are with me. So what is W here? W is the size of input. Okay. In our example, it is 5 cross 5. So W is 5. What is F? Size of filter. It is 3 cross 3 in our example. So here you can see that F is 3. Then P is amount of padding. I'll tell you what is padding, but in our example, padding is 0. So 2 into 0. And S is stride value. In our example, we are shifting by 1. We are shifting by 1. We can also shift by 2. Right? तो वहां पे हम दो कॉलम छोड़ के आगे जाएंगे. So if it is shifting by 2, then stride value would be 2. If it is shifting by 1, it would be 1. In our example, it is 1. So it is 1. You can see that. Now, if you compute this 5 minus 3 plus 0 divided by 1 plus 1, it results in 3. And you can see that the size of output is 3 cross 3. I'm discussing operation of one convolutional layer, and such so many convolutional layers are available in your convolutional neural network. I repeat the process. Right. What we do, we input original image to first convolutional layer. That image may have resolution in thousands, right? So what it does, like we consider one kernel, maybe of 3 cross 3 or 5 cross 5. It passes through different blocks of input image, and all the pixels of input image are processed, and finally we get such kind of output, the reduced matrix, reduced size image from the convolutional layer, which is then passed to activation function and then pooling layer, right? Now this is one block, such multiple blocks are there. So you can imagine that by like what amount the image size is reduced. Right? Any doubt in this operation, because this is the core of the convolutional layer, a convolutional, yeah, neural network. Any doubt in this? If you have any question, doubt, let us please discuss before we move forward. Any question in this? I hope it is clear. Yeah, I tell you padding. Yeah, after this, I'm going to tell you about padding only. Other than that, any other question? In our example, padding is 0, but why it is 0 and what can be the value of padding, I'll tell you. Okay, but okay, fine. If no question, let me know whether it is clear to you or not, the convolution operation. Write yes or no in chat box. Okay, Kirtan, I'll repeat. I'm expecting more answers. Okay, fine. I hope rest of you have also understood, and if not, then I am repeating this operation. Kirtan, be with me. I repeat this, that how it works. Okay. Okay. Kirtan, suppose we have assumed that our input image has dimension 5 cross 5. Okay. If input image has 5 cross 5 dimension, then how many pixels are there? Kirtan, right answer in your chat box. How many pixels are there in your image? Dimension is 5 cross 5. How many pixels are there? You can also unmute Kirtan. Kirtan, you need to be with me if you want to understand that how it works. Or if you don't have any idea, then you need to let me know that you don't know that how many pixels are there. And that's why I'm requesting you to unmute your mic. Yeah, but I would love to hear your voice if you can unmute, right? Okay, you don't know, I'll tell you. Kirtan, unmute, please unmute. Don't worry, I am there to explain you, right?
Yes, ma'am.
Yeah, say Kirtan, I'll explain you. We have 5x5 image, okay?
Yes.
So this many pixels are there. Can you see these pixels?
Yes, ma'am. Yes.
1, 0 are the pixel values and 5x5 is the dimension. So 25 pixels are there. Now this is black and white image. So channel is only one. So 5x5 x 1. So only 25 pixel values are there. If it would have been sorry, if it would have been color image, then three channels would have been there: red, green, and blue. And for each channel, different intensity value would have been there for each pixel. अगर तीन चैनल होती है तो हर एक पिक्सल के लिए तीन इंटेंसिटी वैल्यू होती है: रेड इंटेंसिटी वैल्यू, ग्रीन एंड ब्लू. बट यहाँ पे हमारे पास कलर इमेज नहीं है. हमने एज्यूम किया है कि हमारी इमेज ब्लैक एंड व्हाइट है. And its dimension is 5x5. So total 25 pixel values है जो हमें न्यूरल नेटवर्क को फीड करनी है टू फीड द एंटायर इमेज. अगर हम एक इमेज को फीड करना चाहते हैं, इनपुट देना चाहते हैं न्यूरल नेटवर्क को, तो हम इमेज को कैसे इनपुट करते हैं? वी इनपुट ऑल द 25 वैल्यूज टू न्यूरल नेटवर्क. अगर ये ट्रेडिशनल नेटवर्क रहता, ट्रेडिशनल न्यूरल नेटवर्क लाइक फीड फॉरवर्ड न्यूरल नेटवर्क, तो हमें कितने न्यूरॉन्स चाहिए इन इनपुट लेयर? 25 न्यूरॉन्स चाहिए. क्यों 25 न्यूरॉन्स चाहिए? बिकॉज हमारी इमेज में 25 पिक्सल्स है, तो हमें 25 न्यूरॉन्स चाहिए. अगर ये कलर इमेज होती तो हमें 25 इंटू 3 75 न्यूरॉन्स चाहिए फीड फॉरवर्ड न्यूरल नेटवर्क में. बिकॉज 75 हमारे पास इंटेंसिटी वैल्यूज है, तो हमें 75 चाहिए होते. फाइन. अब हम क्या कर रहे हैं? वी आर नॉट यूजिंग फीड फॉरवर्ड न्यूरल नेटवर्क. इफ वी यूज कॉन्वोल्यूशनल न्यूरल नेटवर्क, तो हमने इसके आर्किटेक्चर में देखा कि हमारे पास पहला कौन सा लेयर रहता है? कॉन्वोल्यूशनल लेयर. इफ यू सी दिस आर्किटेक्चर, हमारे पास पहले ही इनपुट लेयर के पास कौन सा है? कॉन्वोल्यूशनल लेयर. तो हम ये इनपुट किसको देते हैं? कॉन्वोल्यूशनल लेयर को. जो इनपुट हम कॉन्वोल्यूशनल लेयर को दे रहे हैं, तो कॉन्वोल्यूशनल लेयर में हम कैसे प्रोसेस कर रहे हैं इमेज? वी चूज द कर्नल विच इज द सेट ऑफ वेट वैल्यूज. ओके. अगर हमारे पास कॉन्वोल्यूशनल न्यूरल नेटवर्क नहीं होता, फीड फॉरवर्ड न्यूरल नेटवर्क है जिसमें हमारे पास इधर 25 और कलर इमेज है तो 75 न्यूरॉन वैल्यूज है, तो हमारे पास कितनी वेट वैल्यूज होती? 75. 25 या 75, उतनी वेट वैल्यूज हमें चाहिए. बट हमने यहाँ पे वेट वैल्यूज कितनी ली है? ओनली 3x3, 9 वेट वैल्यूज ली है. वी हैव नॉट कंसिडर 25 और 75. Right? We are considering only how many weight values? We are considering only 9, 3x3. So when we are considering 3x3 and when we have 25 pixels to process, how can we process 25 pixels using 9 weight values? आर यू गेटिंग माई पॉइंट? हमारे पास
Yes, yes,
25 पिक्सल वैल्यूज है और हमने वेट वैल्यूज कितनी ली? ओनली 9. तो हम
ma'am.
25 पिक्सल वैल्यूज को 9 वेट वैल्यूज से कैसे प्रोसेस करेंगे? नहीं हो सकता. एट ए टाइम इट इज नॉट पॉसिबल. सो हाउ वी आर डूइंग? ओके, 9 वेट वैल्यूज है तो एटलीस्ट वी कैन प्रोसेस 9 पिक्सल वैल्यूज फ्रॉम दिस इनपुट इमेज. सो एट ए टाइम वी आर प्रोसेसिंग ओनली 9 पिक्सल वैल्यूज ऑफ इनपुट इमेज using this 9 weight values. Okay, we multiply them, we sum up them, and we get this 4. Okay, अब बाकी के पिक्सल्स का क्या? लेकिन so what we do, we move this block, we shift this block to next set of pixels value. तो आप यहाँ पे राइट साइड के फिगर में या फिर यहाँ पे ही देखो. So this is my next block of pixel values. तो अब मैं ये कर्नल से ये वाले ब्लॉक की पिक्सल वैल्यूज को प्रोसेस करूंगी. Then I get 3. If I multiply and then sum up, then I get 3. Then I process the next block. Okay, then I process the next block. देखो अब मैं एक रो नीचे आई, पहले मैं कॉलम वाइज गई, अब मैं एक रो नीचे आई. राइट, अभी नेक्स्ट ब्लॉक, this is next block. So this is how using the small number of weight values, we are processing the entire image. We are not processing entire image in one go. हम ट्रेडिशनल न्यूरल नेटवर्क में क्या करते हैं? एक ही साथ पूरी इमेज के सारे पिक्सल वैल्यूज हम फीड कर देते हैं, तो पूरी इमेज एक ही साथ एक ही गो में प्रोसेस हो जाती है. लेकिन यहाँ पे हम क्या कर रहे हैं? वी आर processing whole image in blocks. पहले एक ब्लॉक को, इमेज के एक ब्लॉक को प्रोसेस किया, नेक्स्ट ब्लॉक, नेक्स्ट ब्लॉक, नेक्स्ट ब्लॉक. तो कितने ब्लॉक्स होंगे? इट डिपेंड्स ऑन द साइज ऑफ द फिल्टर, इट डिपेंड्स ऑन द साइज ऑफ कर्नल. अगर मैं 5x5 लेती तो ये पूरा इमेज ही एक साथ में प्रोसेस हो जाता है. बट ये सैंपल इमेज है, तो आपको ये रिजोल्यूशन तो कंसिडर करना ही नहीं है, बिकॉज हमें पता है कि रियलिटी में 1000 में डायमेंशन रहता है, राइट? सो वी प्रोसेस इनपुट इमेजेस नाउ ब्लॉक बाय ब्लॉक. अदरवाइज हम ट्रेडिशनली क्या करते हैं, पिक्सल बाय पिक्सल हम प्रोसेस करते हैं इमेज को, बट इंस्टेड ऑफ दैट ब्लॉक बाय ब्लॉक हम प्रोसेस कर रहे हैं. सो अभी हम ऐसे ब्लॉक बाय ब्लॉक करते हैं तो हमें कन्वोल्यूशनल लेयर से आउटपुट क्या मिलता है? ये जो पिंक कलर का मैट्रिक्स है ना, दैट वी गेट एज आउटपुट. It is a feature vector, right? So we get this output at the end. Is this clear now, Kirtan and everyone?
Yes, ma'am.
Right? That how do we process it? Kirtan, may I move forward then if it is clear, and if it is
Yes,
yet not clear? Huh.
yes, ma'am. Yes, ma'am. Please.
Yeah. So this is how we process it. Now, okay, we have to discuss regarding padding and stride. Okay. So what is padding? We can observe that the size of output is smaller than the input. Okay. Output is given in pink color matrix and input is given in green color matrix. So we can observe that the size of output is smaller than input. Now to maintain the dimension of output as in input, we use padding. To maintain the dimension of output as in input, we can use padding. Padding is a process of, listen carefully, what is padding? Padding is a process of adding zeros to the input matrix symmetrically. Adding zeros to the input matrix symmetrically. Adding padding to an image allows for more accurate analysis of images. So, अगर ये मेरा 3x3 आउटपुट है, मैं एक रो यहाँ पे 0 की डाल दूं और एक कॉलम भी 0 की डाल दूं. मैंने कहा है ना सिमेट्रिकली, मतलब आपको रो ऐड कर रहे हो तो कॉलम भी ऐड करना पड़ेगा. सो यू कैन ऐड इट. तो वो क्या बन जाएगा? अगर मैं एक ऐड करूंगी तो 4x4 बन जाएगा, दो ऐड करूंगी तो 5x5 बन जाएगा. So in that case, the size of my output would be same as input. So padding is usually used to maintain the size of size of the image. So for example, if padding is set to 0, in our example, it is set to 0. Okay. So if padding is set to 1, if padding is set to 0, nothing is added. If padding is set to 1, there will be 1 pixel border added to the image with an pixel value of 0. जैसे मैंने कहा, अगर padding 1 है तो एक रो एक कॉलम में 0 का ऐड कर दूंगी ये मैट्रिक्स में, आउटपुट मैट्रिक्स में. There are two types of results to the convolution operation. One in which the convolved feature is reduced in dimensionality as compared to the input, जो हमारे केस में है. Convolved feature is reduced in dimensionality as compared to the input, and the other in which the dimensionality is either increased or remains the same. Right? So this is done by applying padding. अगर हमें reduce करते हैं और हमें अगर उसकी size increase करना है, or if we want to keep it same as input, then we use padding. Okay, so that is what padding, the row and columns of zeros are added. That is called padding. Okay, now in case, okay, this we discussed related to black and white image. Now what if the image is color image? Okay, this is regarding padding. When we augment the 5x5x1 image and then apply the 3x3x1 kernel over it, we find that the convolved matrix turns out to be of dimension 5x5x1. if it is padded with zeros. Okay, we can skip it. इस पे ध्यान देते हैं. हमने जो इनपुट इमेज कंसिडर की थी हमारे एग्जांपल में, दैट वाज ब्लैक एंड व्हाइट 5x5x1. बट इमेज में भी, इनपुट इमेज में भी कलर इमेज. अगर इनपुट इमेज कलर इमेज है तो मैंने आपको बताया था कि वी विल हैव 3 मेट्राइसेस for intensity values. तो आप देख सकते हो यहाँ पे, the first one is for red channel, second is for green channel, and the third is for blue channel. So we have 3 such matrices. Now when we have 3 such matrices, we need 3 kernels to process these 3 matrices. right? So in case of images with multiple channels like RGB, the kernel has the same depth as that of the input image, and matrix multiplication is performed between, you can see that matrix multiplication is performed between uh, like this kernel values and input values, right? So can you observe this figure? I tell you that here for the red channel matrix, this is the kernel. This is for green channel and this is for blue channel. ओके तो ये जो प्रोसेस हो रहा है इंटेंट क्या हो रहा है प्रोसेस मैंने जैसे बताया था ये वैल्यूज ये ब्लॉक की वैल्यूज के साथ मल्टीप्लाई करना है और फिर उनको ऐड करना है एंड यू विल गेट वन वैल्यू लाइक दिस ओके नाउ दिस इज द वैल्यू प्लीज बी विथ मी ओके प्लीज बी विथ मी आपको ये ध्यान से देखना है कैसे हो रहा है 3 कर्नल्स है 3 मेट्राइसिस है फॉर 3 कलर चैनल्स देखो ऐसे होता है कलर चैनल्स कैसे होती है एक कलर इमेज को ऐसे हम रिप्रेजेंट करते हैं एक पिक्सल की 3 वैल्यूज इंटेंसिटी वैल्यूज रहती है ब्लू इंटेंसिटी वैल्यू ग्रीन इंटेंसिटी वैल्यू एंड रेड इंटेंसिटी वैल्यू कौन सा कंपोनेंट ज्यादा है अकॉर्डिंगली उसकी इंटेंसिटी वैल्यू है इफ रेड कंपोनेंट इज हायर देन इंटेंसिटी वैल्यू ऑफ रेड इज हायर इन दिस केस सी दिस फर्स्ट पिक्सल right 35 9 and 4 because blue component is low in this for the first pixel so its intensity value is only 4 okay so that is how we represent color image okay and 3 kernels have been chosen now the same block like parallelly we are doing this but you can see that the same block jo yahan pe hai waisa hi block yahan pe hai waisa hi block yahan pe hai so we multiply those values in matrix with kernel values and then we sum up them. तो ये और ये sum up करने से मुझे एक value मिली यहाँ पे. So वैसे 3 color channels के लिए 3 values मिलेगी and we add them to get one value. So actually this is how the output matrix is constructed for this color images. I hope this is clear. हम क्या कर रहे हैं? The operation is clearly mentioned in this slide. Is it clear to everyone? Is this clear to everyone? Because it is necessary to understand how color images are processed with CNN or with convolutional layer, right? Not entire CNN, but how color images are processed by convolutional layer or how convolution operation is carried out for color image. Is this clear, everyone? You can write your answer in chat box. Because this is the core of this convolutional neural network. आपको यही अच्छे से समझना है तब जाके आप implement कर पाओगे फ्यूचर में इसको इमेज डेटा सेट प्रोसेस करने के लिए. Okay. I hope it is clear to everyone, or if not clear, then you can mention in chat box. Then I can repeat it. Okay, so I assume that it is clear to everyone because there is no message to repeat it. Fine. So this is how color images are processed. Okay. Remember that we are still on convolutional layer, first component of convolutional neural network. I have yet not discussed the remaining 3 components. We are discussing the first component. Fine. So this is like how color image is processed by convolution layer. Fine. So, and at the end, we get such kind of output matrix. And here also, in this example, okay, listen, here we have padding. देखो यहाँ पे एक रो एंड कॉलम पैडिंग की ऐड की गई है, राइट? सो दिस इज कॉल्ड पैडिंग एंड आप ये भी देख सकते हो कि ये जो इनपुट इमेज है उसका डायमेंशन क्या है, कितने रोज एंड कॉलम्स है? यहाँ पे डैश 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 दिखाया है कॉलम में और रो में. सो बहुत सारे हो सकते हैं, बहुत सारे हो सकते हैं, लेकिन आउटपुट मेरा क्या आया, ऐसे मेरा आउटपुट जनरेट हो रहा है, देखो. सो द साइज ऑफ आउटपुट मैट्रिक्स इज ऑलवेज reduced, right, compared to input matrix. So all the results are then, okay, this is how. So here we have seen RGB images, but there are not only RGB images. RGB images have 3 color channels, red, green, and blue. But there are a number of such color spaces in which images exist. For example, grayscale images, HSV images, CMYK images. These are the different representations of color images. So in CMYK, you can have more channels. So to process them, we need such kind of operation, such kind of computation in convolution layer. Now you can imagine how computationally intensive things would get once the images reach dimensions, say 8,000. The role of convolutional layer is to reduce the images into a form which is easier to process without losing features. Please remember, without losing features. Yesterday, someone asked me that do we lose features? Do we lose information? No, without losing features, which are critical for getting a good prediction, because features should be maintained to get correct prediction. And this is important when we have to design an architecture which is not only good at learning features but also good uh, to also good, which is also scalable to massive data sets. Okay, so this is how it works. Fine. Same example, like how it is processed, different weights and bias for various rounds. ये एक राउंड में पूरा प्रोसेस होता है, फिर नेक्स्ट राउंड के लिए अगेन डिफरेंट वेट्स होते हैं, जैसे हमारा नॉर्मल न्यूरल नेटवर्क में रहता है कि वेट्स गेट अपडेटेड. So in next round we will have different weight values. So here also in next round we will have different weight values. So here you can see that this is W0 first round के लिए जो हमने आगे previous slide में देखा. Now this is for next round, right? V1. ओके, मैं थोड़े मैसेजेस से देख लेती हूँ. कर्नल चैनल में -1011 कैसे आया, वो हम लेते हैं. इनिशियली हम रैंडमली चूज करते हैं वेट वैल्यूज. टू चूज द वेट वैल्यूज देयर आर डिफरेंट वेज. हमारे फर्स्ट राउंड के लिए हमें वेट वैल्यूज चाहिए. जो वेट वैल्यूज हम लेते हैं, there are different ways, but the normal way is we randomly choose weight values, and usually we choose weight values between 0 and 1. ओके, सो फर्स्ट राउंड के लिए हम चूज करते हैं एंड फिर वो अपडेट होती रहती है नेक्स्ट राउंड्स में. सो आफ्टर द फर्स्ट राउंड वेट वैल्यूज गेट अपडेटेड. इफ यू रिमेंबर, हमने आगे ये डिस्कस किया था फर्स्ट यूनिट में कि राउंड खत्म होते कौन से पैरामीटर्स अपडेट होते हैं, राइट? सो दिस आर द वैल्यूज फॉर नेक्स्ट राउंड, वेट वैल्यूज एंड सो ऑन. तो ये होते होते मल्टीपल राउंड्स में आपका नेटवर्क ट्रेन होता है विद द सेम सेट ऑफ इमेजेस. ओके, देखो ये कैसे हो रहा है, मैं दिखा रही हूँ आपको. सी दिस, द नेक्स्ट ब्लॉक, राइट? ऐसे करके पूरा प्रोसेस होता है. ओके, नाउ लेट्स टॉक अबाउट द नेक्स्ट component or next layer in sequence, that is activation layer. The convolutional layer generates a matrix that is much smaller in size than the original image that we have seen. Now this matrix is run through an activation layer. ये पूरा matrix will be passed through activation layer, which introduces non-linearity to allow the network to train itself via backpropagation. Okay, so the job of activation layer is to introduce non-linearity to allow network to train itself via backpropagation. And the activation function usually we use in CNN is ReLU. So this activation function is usually used, though we have other activation functions like leaky ReLU, randomized leaky ReLU, parameterized ReLU, exponential linear units, then scaled exponential linear units, then hard 10H, then soft 10H, soft sine, soft max, soft plus. So many, this activation functions are there, but this is typically used, say this ReLU. Okay, now this is another important layer component of convolutional layer. Okay, be with me to understand this. Pooling layer. What is pooling? Okay, pooling is see its name. जो हमें कॉन्वोल्यूशनल लेयर से रिड्यूस्ड साइज का मैट्रिक्स मिला है, वी विल फर्दर रिड्यूस इट. सो जॉब ऑफ द पुलिंग इज टू डाउन सैंपल the image to reduce the size of the matrix. So a filter is passed. Here we use another filter. हमने convolutional layer के लिए भी filter use किया था, kernel, जो हमने example में देखा कि 3x3 था. Now जो हमें output मिल रहा है convolutional layer से, उसको process करने के लिए भी we have to choose a filter. Okay, so we choose a filter which is passed over same process. उसको भी हम ऐसे shift करेंगे different blocks में. But कौन से different, किसके different blocks? जो हमें convolutional layer से output मिला है, वो matrix में हम उसको shift करेंगे. मतलब block wise we will process it. So filter is passed over the results of the previous layer and selects one number out of each group of values. So this way, like we process, you can see on right hand side, I have kept it. Suppose हमारा एक 2x2 का फिल्टर है, तो ये पहला ब्लॉक, ये नेक्स्ट ब्लॉक, बट यहाँ पे आप देख सकते हो कि स्ट्राइड इज नॉट वन, right? So let me discuss more about this pooling. Actually, we have two types of pooling: max pooling and average pooling. So what is max pooling? अभी ये समझो, max pooling क्या करता है? Max pooling returns the maximum value from the portion of the image covered by the kernel. तो हमारा 2x2 kernel है, तो ये मैंने 2x2 का ब्लॉक कंसिडर किया. What is this now? प्लीज लिसन केयरफुली. ये क्या है? पूरा मैट्रिक्स जो मुझे कॉन्वोल्यूशनल लेयर से आउटपुट मिला है वो है. ये कॉन्वोल्यूशनल लेयर से जो आउटपुट मिला है हमने एक्टिवेशन लेयर में पास किया, और उससे जो आउटपुट मिला है दैट इज दिस मैट्रिक्स. अब उसको हम मैक्स पूलिंग लेयर में प्रोसेस कर रहे हैं. How are we processing it? So we have chosen filter again. और हम क्या कर रहे हैं उसको, मतलब फिल्टर हमने 2x2 का लिया, तो what we will do if it is max pooling, ये ब्लॉक में मैक्सिमम वैल्यू कौन सी है? तो मैक्सिमम वैल्यू इज 100, तो मेरे आउटपुट मैट्रिक्स में 100 आएगा ये ब्लॉक के लिए. फिर ये नेक्स्ट 2x2 ब्लॉक में मैक्सिमम वैल्यू कौन सी है? 184. सो यहाँ पे 184 आया. नेक्स्ट 2x2 ब्लॉक में मैक्सिमम वैल्यू कौन सी है? 12. सो 12 आया. एंड देन 45. सो 45 विल बी output in output matrix for this block. So this is max pooling. Average pooling, as its name suggests, name क्या suggest करता है? Take average. So again, our 2x2 pooling we have considered. So we have to take average of these four values: 31 plus 15 plus 0 plus 100 divided by 4. Average will be 36. Here 28 plus 184 plus 70 plus 38 divided by 4. The average would be 80. Right? You can verify. I told you yesterday that keep notebook and pen with you. Right? So this is how average pooling works. So now you see that original image was, let's say it is 5x5 or 100x100. उससे हमें convolutional layer से output मिला 4x4, which is passed through activation layer. And again, suppose we have 4x4 output. Now this 4x4 output from previous layer is passed to pooling layer. Pooling layer further reduces its size. So you can see that this is the size. Okay, now how do we decide the size of pooling output of the pooling layer? So this is the form W minus F divided by S plus 1. So W is again input 4 minus F filter 2 divided by 2 plus 1. So that gives us the size of output layer. Sorry, size of the output. So this is how like pooling works. You can see this allows the network to train much faster, focusing on the most important information in each feature of the, because ये block में कौन सा important feature है? This one. So this helps us to focus on most important feature, right? So similar to a convolutional layer, the pooling layer is responsible for reducing the spatial size of the convolutional feature. Yeah. And this is to decrease the computational power required to process the data. अगर आप original size की image को ही process करते रहोगे throughout all the layers, then it requires higher computational power. But we are reducing size because we want to decrease the computational power required to process the data through dimensionality reduction. So dimension of image is reduced over the layers so that processing, the training would be faster and less computation power would be required. This would be the advantage when we process image using this convolutional neural network. In addition, it is useful for extracting dominant features. When you use max pooling, क्या हो रहा है max pooling में? Dominant features extract, uh, which are rotational, right? Which are rotational and positional invariant. Okay, so max pooling also performs noise suppressant. Max pooling is very popular. It performs noise suppressant also. It discards the noisy activation altogether and performs denoising along with dimensionality reduction. So that is the advantage of max pooling. Remove हो जाता है. On the other hand, average pooling simply performs dimensionality reduction as noise suppressing as a noise suppressing mechanism, and we can say that max pooling performs a lot better than average pooling क्योंकि उसमें dominant features extract होते हैं and noise भी reduce हो जाता है. So the convolutional layer and pooling layer together, they form the ith layer of convolutional neural network, one block, or you can say ith layer, right? So convolutional layer, activation layer and pooling layer, they together form the ith layer of the convolutional neural network. And depending on the complexity of the images, the number of such layers are increased in convolutional layer for capturing the low level details even further, but at the cost of more computational power, because आप जितने ऐसे layers increase करते जाओगे computation power चाहिए, लेकिन अगर आपको low level features भी चाहिए, then you need to add more such layers. So after going through the process which we have just discussed, we have successfully enabled the model to understand the features, right? So now moving on, we are going to the next component of the convolutional layer, that is fourth component, fully connected layer. Right? So this is the last layer, and this is like feed it to a regular neural network for जो अभी तक process होके image आया first 3 layers में, उसको हम regular neural network में यहाँ pass कर रहे हैं, which is our feed forward neural network. Okay, this is our, ये देखो, ये जो पहले सारा दिख रहा है आपको, वो convolutional and convolution plus pooling layer के combinations है. And finally we have fully connected neural network, that is like fully connected, जो हमारा normal traditional neural network है. So that is used for classification. So the first part is to reduce the size of the image, and the last layer is to do the classification. Please remember, the first part, the first layers of the convolutional layers are just to reduce the dimension of the image, and the last layer, fully connected layer, is to classify your image, right? So is this clear? Fully connected layer, I'll discuss again tomorrow, because I need to discuss it in like sufficient depth. So we will discuss tomorrow. Now I would like to take your questions related to this. If you have any questions related to today's discussion. Yeah, thank you, Shruti. Any question, students?